Hello student, today we are going to discuss about asset properties in transaction. In last lecture we have discussed about what transaction is, what operations are in transaction and what is the life cycle of the transaction or states of transaction. Now we will discuss about the properties of transaction. First we will discuss about asset property. It is important to ensure that the database remains in a consistent state before the transaction and after the transaction. To ensure the consistency of the database, certain properties are followed by all the transactions occurring in the system. These properties are called asset properties of a transaction. It includes atomicity, consistency, isolation, and durability. These whole property will be known as asset property. First one, we will discuss what atomicity is. Atomicity is a property ensure that either the transaction occurs completely or it does not occur at all. In other words, it ensures that no transaction occurs partially. That is why it is also referred to all or a nothing rule. For example, suppose account A has a balance of 400 rupees and B has an amount of 700 rupees. Account A is transferring 100 rupees to account B. Let's say first operation passed successfully. That means 100 RS is debited from account A, but it will not credit it to account B. Then we will say a transaction is partially completed because it is not credited into the account of B. This is not acceptable in banking system. So either the transaction should fail without executing any of the operation or should process both the operations. Fine. I hope I am clear with atomicity. It means that the whole transaction will be performed or nothing will happen. Fine. If our transaction fails in middle, we will roll back our transaction to previous committed state. Fine. Next one is your consistency. This property ensures that integrity constraints are maintained. In other words, it ensures that the database remains consistent before the transaction and after the transaction. It is the responsibility of DBMS and application programmer to ensure the consistency of database. For example, account A is having a balance of 400 rupees and it is transferring 100 to account B and C both. So we have two transactions here. Let's say the transaction runs concurrently and both the transaction reads 400 balance. In that case, the final balance of A would be 300 instead of 200, and this is wrong because it should be there is a two transaction and we are transferring 100 rupees to both transaction, that is B transaction and C transaction respectively. So value should be or balance of A would be 200, but if we are reading it as a 300, then it is incorrect. If the transaction were to run in a isolation, then the second transaction would have read the correct balance of 300 once the first transaction will run or went successfully. So we always ensure the consistency and this will be maintained by the isolation. Third one is our third property of our transaction is isolation. This property ensures that if multiple transactions can occur simultaneously without causing any inconsistency. During execution, each transaction feels as it is getting executed alone in a system. It means that every transaction should be isolated with another one or another transactions. Fine. Next one is your durability. What durability is? Once a transaction completes successfully, the changes it has made into the database should be permanent even if a system is failed. The recovery management component of a transaction system ensures the durability of your transaction. It also ensures that these changes exist permanently and are never lost even if your system is failed in any kind or any case. It is the responsibility of recovery manager to ensure durability in your database. Fine. Thank you. Next, we will discuss about problems of concurrency. If simultaneously multiple transactions are working, then what issues will occur? We will discuss it in this. When multiple transactions executing concurrently in a unrolled or unrestricted manner, it uncontrolled or unrestricted means ki there is no rules for transaction to be executed, then it might lead to a several problems, such as problem are called concurrency problem. Here are four problems of concurrency. First one is your dirty read problem, second one is your unrepeatable read problem, third one is your lost update problem, and fourth one is your phantom read problem. Here first we will discuss what dirty read is. When we say reading the data written by an uncommitted transaction is called dirty read. Uncommitted, it means if I am reading a value of transaction T1 and transaction T1 is not committed transaction, then I will say it is dirty read. This is called a dirty read because there is always a chance that the uncommitted transaction might roll back because of failure. Thus, uncommitted transaction might make other transaction read a value that does not even exist. This leads to inconsistency of your database. Dirty read does not leads to inconsistency always. It always not be inconsistent, but in a situation when the previous uncommitted transaction fail, then our transaction will be in inconsistent state. It becomes problematic only when the uncommitted transaction fail and roll back due to some reason or a failure. Fine. Here we have an example of dirty read. We have two transactions that are T1 transaction and T2 transaction. We are seeing that T1 is initially reading a value of data item A. Then T1 update the value of A in the buffer, that is called writing operation. And before committing, we are seeing T2 transaction is reading the value that will be returned by transaction T1, and it is called dirty read because the transaction T1 is still now not committed. And before T2 reads the transaction, T2 writes the transaction on data item A and commit it. Now we are seeing transaction T1 is failure. Due to the failure and rollback of transaction T1, a transaction T2 will be in inconsistent state. Therefore, it is called a problematic situation. Next one is your unrepeatable read problem. This problem occurs when a transaction get to read unrepeated, that is different value of the same variable in its different read operation, even when it has not updated its value. Suppose in example we are seeing here also two transactions are there, that is T1 and T2. Initially T1 reads the value of X and then T2 again reads the value of X, that will be 10 only. Afterwards, T1 update the value of X from 10 to 15 in the buffer. Now again transaction reads the value of X and he saw it is 15. Then transaction T2 will think there is only one transaction, because he will think he will be running in isolation mode. And if he is isolated, who have updated the value, because previously he had read 10 and now he is reading 15. So he will get confused what will be the correct value, as he T2 wonder how the value of X got changed, because according to it he is running in isolation. Fine. So this is also a problem of your concurrency. Third problem is lost update problem. This problem occurs when multiple transactions executing concurrently and update from one or more transaction get lost. In here we have an example of lost update problem. We have two transactions that are T1 and T2. Here T1 reads the value of A. We will say it is 10. Next T2 updates the value without reading it to 15. Now T2 blindly T2 updates value A. T2 blindly write A25 in the buffer and T2 commits. When T1 commit, it writes A equals to 25 in the database. T1 writes the overwrite value of A, and thus updated value from T1 lost because T1 has updated value of 15 and now there is no 15 value because transaction T2 had performed a blind write. What blind write is? So blind write is without reading a value, performing a write operation is called blind write. To ensure consistency of the database, it is very important to prevent from all of these problems. Fine. Thank you.